Hey everybody. So I added an extra, section that wasn't really in the textbook because I dedicated to just questions specifically for two triangles. The steps are the exact same, but for some reason when two triangles are put together, it makes things a little harder for some people. So I'm going to dedicate this worksheet to just questions about two triangles. So in this case, our job is to find BC. Okay, so we're thinking, okay, if I could use SOHCAHTOA, I could find BC pretty easily, right? Because I have an angle, I don't have an opposite side, I don't have an adjacent side, I also don't have an hypotenuse side. So what am I going to do then? Well, what I could do is take a look at my other triangle and see if my other triangle will help me at all. Okay, so I need to find, I notice that both triangles share BD. Correct? So chances are, if I could just find BD, that would be enough for me to solve this triangle. So let's take a look at this triangle and solve for BD. Well, here's an angle, which means BD is technically the opposite side. Okay? And this is my hypotenuse. Now I know this is my adjacent, but there's really no need to add it there. It just makes it cluttered. But if you're in the habit of doing so, go for it. Okay, so now to find BD, I'm just going to call it BD, I'm going to need to use, let's use a different color. I'm going to need to use H because there's a number there, and obviously I want BD. So, which one has SOHCAHTOA? Which one has opposite and hypotenuse? Sine. So sine of 26 is equal to opposite, so BD over hypotenuse over 22.9. Okay? So by now, hopefully, you should be able to solve this in just one step. Multiply both sides by 22.9 times sine 26. That will equal to BD. Okay? Type all this in your calculator. My calculator is just Desmos for now. So it's 22.9 times sine of 26. Oops. And there's your answer. Oops. 10.04. So BD equals to 10.04. Okay? Now that I know that this is 10.04, I can go back to this triangle to solve for BC. So this is where the diagram might get a little bit confusing. You're going to have too many things labeled in here. I'm going to use, I don't think it matters. I'm taking way too much time with this. Okay, let's go purple. So if this is my angle, then over here is still my opposite side. Oh, perfect. That makes things easier. So this is still my opposite side. And this is my 90-degree angle, which means this is my hypotenuse, which means this is my adjacent. Okay? Now, which ones do I need to use? Well, I obviously need to use this because that's the side I'm trying to find, and I should be using this side, BD, because we have a value of 10.04 that we solved last time. So which one has opposite and hypotenuse? Opposite hypotenuse, it's still going to be sine. So sine of 49 is equal to opposite, which is BD, over hypotenuse, over x. Okay? Now in this case, we're going to do the same thing, just multiply both sides by x. So I'm just going to show you the long step here. Let's use red for that. Multiply both sides by x. So times x times x. Well, if I multiply both sides by x, what happens? I'm just going to cross this off. Well, these two cancel out, right? So I'm left with x sine 49 equals, well, what was BD again? 10.04. Let me use green so you can see. So 10.04, 10.04. 10.04 divided by nothing. Well, divided by 1 because the two x's are cancelled out. Now, we need to do an extra step here. And that extra step is the fact that I need to divide both sides, because I want x by itself, by sine of 49. Sine of 49. So then these two will cancel, and x will just equal to whatever 10.04 divided by sine 49 is. 10.4, or is it 10.04? 10.04 divided by sine of 49. Oops. That gives you 13.3. X equals 13.3. So therefore, BC is equal to 13.3 centimeters. Okay? So as you can see, the steps are the exact same. There's nothing different about them. Okay. So Evelyn is lying on the ground between two trees, 100 meters apart. Tree 1, tree 2, Evelyn. 100 meters apart. Now, can I assume that Evelyn's smack dab in the middle at 50 apiece? 50, 50? No, you cannot. The shorter tree is 10 meters tall. So let's say this is 10. Now the angle of elevation to the top of the trees are 13 and 18. Okay? 13 and 18. Now, we know that, well, let's use intuition for a second. Where do you think the 13 will go, and where do you think the 18 will go? Well, the higher the angle of elevation, the taller the object, right? Think about craning your neck. If you look forward, the higher you look up, the higher the angle of elevation, the taller the thing you're looking at is. Which means this must be 13, and this must be 18. Okay? Now our job is to find out how much taller is this tree. Well, to find out how much taller that tree is, we need to first find out how tall it is in the first place. So if I look at this triangle, and only this triangle on this side, only this triangle, the problem is I have an angle, but that's all I have. I can't assume this is 50. So what I need to do then is first find this length, because if I can find that, I just need to subtract 100, or to take that away from 100, and that'll give me the length of that. Okay? So, let's look at the triangle on this side then. Well, there's 90 degrees, which means this is my hypotenuse. This is 13 degrees, which means this is my opposite. And whatever's left over must be my adjacent. Now I gotta remind myself, what am I trying to find again? What am I trying to find? Well, I'm trying to find this side, right? The bottom length, so let's call that x. So, I need that side, my adjacent, and out of my hypotenuse and opposite, which one has an actual value? Right there. So which one, sine, cos, or tan, uses opposite and adjacent? SOHCAHTOA, it's T. TOA. So tan of 13 is equal to opposite, which is going to be 10, over adjacent, which is going to be x. Okay? And do the same thing above, multiply both sides by x. Okay, so this will cancel out with that, and I'm just left with x tan 13 is equal to 10. Okay? And then I could divide both sides by tan of 13, tan of 13, and then x will give me whatever tan divided by tan of 13 is. Tan of 13 is 43.3. Now am I done? No, because this is equal to 43.3, right? Which means that the length we actually care about, this length, will be 100 minus 43.3. 100 minus 43.3, and that will give me 56.9. Okay? 7, not 9. And then we got 9 from 56.7. So now that I have this side, I can then use SOHCAHTOA to find the height of this tall tree. So here's my angle. Look directly across from it. That means this is my opposite side. 90 degrees, which means this is my hypotenuse. And last but not least, this must be my adjacent. Okay? So which side do I want to solve for? Well, which side do I need to solve for? Well, I need to find this height, right? Let's call this h. So which means I need my opposite side. And out of the hypotenuse and adjacent, which one has an actual numerical value? It is my a value. Okay, so which one, sine, cos, or tan, has O and A? Again, that's going to be tan. So tan of 18 degrees is equal to opposite, h, over adjacent, over 56.7. Okay, multiply both sides by 56.7. Tan 18 equals h. And what does that give me? 56.7 times tan 18. 56.7 times tan of 18 is gives me 18.42 or 43. 18.43 equals the height of the tall tree. So therefore, the tall tree is 18.43, which means the small tree was 10, right? So which means the tall tree is 8.43 meters tall. Okay? And see, there's one more example. Yes, one more. Okay. From a small plane, so here is a small plane again, the angle of depression of a sailboat is 21 degrees. So from the small plane. So you are in the small plane, okay, looking forward, and you tilt your head down. Tilt your head down, which means this angle in here is 21 degrees. 21 degrees. Okay? And you see a boat. Okay? The angle of depression of a ferry boat to the other side is 52. So now you're going to look on the other side, and you see another boat. And this angle of depression is going to be 52. The plane is flying at an altitude of 1650. 1650. And we got water across the ground, or on down here. Okay, so you can see our two triangles. Now, let's go ahead and plug those numbers in. So again, Z pattern, which means this is 52. Z pattern, which means this is 21. And what are we asked to find? How far apart are the boats? So what do you need to find? And this one I won't fully solve. I'll let you figure this one out. Here's a triangle. Your job is to find this length. Let's call this x. Okay? And you can do the exact same thing we've been doing. Here's the angle. Label all the sides. Decide whether to use sine, cos, or tan. Solve for x. But that's only half the distance, isn't it? Now you do the same thing on the other side. Here's the other triangle. Okay? 21 degrees. Find this other length. Once you find those two, add them together. You have found your distance. And you're done. Okay? Any questions? Again, please post under math questions. Take care.